In this video, I'm going to show you just review the factoring. And what is factoring? Factoring is the process of turning terms into factors. And before you factoring any problem, first steps you have to try to looking for GCF and try to pull it out of the problems. The GCF stands for the greatest common factor. So look at the example here. Try to factor out this polynomial where I have only one polynomial. Now, so we try to find the greatest common factor, which is GCF. The easiest way to do is when you do with the problem have the variable, like this problem, we have A, B, which are the variables. Try to take care of that first. So you see A is the common factor because A belongs inside this term, and this term, and this term also. So A is common for all four terms. So A is the common factor. Now, as you see, for each term here, for this term here, you have A to the Q, A to the Q, A to the second, A to the second. So the question is, how many A can I take out? Or what is the common factor here? The answer is A squared. You always take out for the variable, you take out the one that have the lowest exponent. So it's this one or that one. So A squared is the lowest exponent, so that will be your G, the common factor of A. Then B is also the common factor, so I pull out a B. And the smallest exponent is B to the first power, which is B. Now for the number, which is 6, 9, 12, and 3. Right here is 6, 9, 12, and 3. You try to find the number that can divisible inside this four number here evenly. So you see, I see that the 3 divide itself in 3 go into 6 twice evenly, 3 go to 9 3 times evenly, and 3 go to 12 4 times evenly, and 3 go to 3 here 1 time evenly. So 3 must be the greatest common factor. So let's see. When you've done that, you take the common factor here, you put it outside, like so, and put the brackets behind it. If you have 4 terms here, you must have 4 terms inside the parentheses. This is how you do. You go back to the first term. Now, before you have 6, you pull out 3, so therefore you have 2 left, because 2 times 3 is 6. Before you have 3 to the cube, but you pull out A to the cube, but now you pull out A squared, you have 1A left. Because A squared times A is A to the cube. That's how you take the answer. Then you have B squared here, but you pull out 1B. Therefore you must have 1B left, because B times B is B squared. Minus 9 here, you have 9 in the beginning, but you pull out the 3 here. So you must have 3 left, because 3 times 3 is 9. You have A to the Q here, and you pull out A squared here, you have 1A left. And you have 1B here, but you pull out 1B, so therefore you have no B here. Plus, for the 12, you have 12 here, you pull out a 3, you have 4 left. You have A squared here, and you pull out A squared, so therefore you have no A here. For the B, you have BQ here, but you pull out 1B, they must have B squared left inside. Minus. You have A squared B and a 3, and you pull out 3A squared and B. You put exactly what you have here. So you have this much, and you pull all of them out. You left with 1, not 0. 1. Because 3A squared times B, gives me 3A squared B times minus 1 is itself right here. Okay, so that is our answer for this problem. Then after this step, you ask yourself how many terms the polynomial has. If the polynomial has 4 terms, then you have to do grouping method. Okay. So look at the example. So once again, before you do anything, always ask yourself, can I pull out the GCF? Look, you have 2 here, 6 here, and 1 fun here, the invisible one here, you have 3 there. So among all 4 terms, you have no common GCF. And one more thing is you have x here, x there, and x there, but no x here. So you see x is not common between all the 4 terms, so as y. So you can really factor out GCF. And you want to factor out because 4 terms, so therefore you do the grouping. So you group the 2 terms together, and you group the last term together. Now I found that if the last term, this third term here, has a minus sign. Right here, put a hint. Always try to pull out the minus, the negative sign for the GCF. And the easiest way to do that is just group the minus also. These 2 terms here, I want to group together and looking for the GCF for this first group. I see that I have 2 is common and x, 1 x only. Because 2 go inside 2 evenly and 2 go inside 6 3 times evenly. You have x here and x there. And this x is the first power, so I pull out that. Now I'm factor out this guy here. So I pull out 2x, so I left here with 1x because 2x times x is 2x squared. And over here I left with 3 because 2x minus 3 is 6x. For the second group here, the GCF will be first be y because y is common between the 2 terms, so I put y. And because the third term is minus, I put a minus like that. Now, put brackets. Now, when you pull out the minus, the negative GCF, we need to reverse the sign inside the factor here. So if you have a minus term here, with minus term here, become a positive term, so a positive x. I pull out a y already, one x left. Right here, you pull out a y, you have 3. Okay, this was positive, become a minus, like that. You always check your answer by taking minus y times x is a minus yx. Minus y times minus 3, which is a positive 3y. Now, when you come to here, you're not finished yet because you don't have a factor. Factor is something times something. You don't have that. You have something plus something. So view this here. Right here you have 1 big term. I put it together like that. Then you minus another 1 big term like that. So you don't have a factor. You have 2 big terms subtract each other. So between the 2 big terms here, that we have the x minus 3 in the common. That is the common factor between the 2 green boxes. How we see that? So I take out the x minus 3, which is the GCF of between these 2 green boxes, between 2 terms here. Take that out. Then I left with, for this box here, I pull out x minus 3, I left with 2x. For this box here, I pull out x minus 3, put a fun, I left with minus y. Now we have a factor. I have something, this something here, multiply something over there. So here our answer. Okay. Now if the polynomial has 3 terms, that means you have a trinomial. Doesn't mean a 3 term. Factor trinomial, usually we use trial error. Now this method here is many times is quite difficult for many students because of the sign, and you have to find all the possibility of factor that you multiply equal to the c term. and you add the b term here. So it's a little bit difficult, so I'm going to go over this method and we'll show you another method that hopefully it will help you to factor out a trinomial. So let's look at the review this method here. We call it trial and error. And this method here, if the third term in the trinomial is positive right here, that means the two factors here, 1, 2, will have the same sign. Either you have, and the n will be whatever the sign of the second term. So if the second term here is positive, right here you have positive. If the second term is negative, you have 2 negative. Now if the third term in the trinomial is a negative, then the two factors will have the opposite sign. So I spelled wrong here. I guess I still spelled wrong. But let's don't worry about it right now. I cannot think spelling right now. I'm thinking of math. So if you have the third term here is in the trinomial is a negative, then this in the two factor here you have two signs that are opposites. You know what's kind of annoying me, so I'm gonna fix it. Opposite. So let me show you the example by showing you the trial and error method and the diamond. That is a new method. It's very easy to do and very visual. And many students found this method is easy to use. Okay, so let me show you some example for that. So for trial and error, I see that all of the term here have no common factor, so I'm okay with that. I'm safe. Go ahead and do the factor. You have x here, x squared there, so you have x there, and here over here. The third term here is a positive, so we have the same sign with the same sign of the second term, which is a positive and positive. And then now you look at the 30. You're going to find a pair of two numbers that multiply equal to 30 and add together equal to 13. Now, here are some possibility of the pairs are 30 and 1, 3 and 10, 2, 15, 5, 6. Okay? So, this method here is work well if you list all the possibilities out and you can see easily which one to pick. But if you try to do it in your head, sometimes it's a little bit harder. So I can see easily 3 and 10 has to be a good candidate. So put 3 and 10 here, and then I'm going to test by multiply back. X times x is x squared. 3 times 10 is 30. To get a 13 here, 13x, you take x times 10 is 10x. 3 times x is 3x. You add together, you have 13x. So bingo. So this is your answer. Okay. It's nice. Yeah. Now, the diamond methods, you draw a cross like that. In the top, you put this number, 30. You just see. In the second bottom, directly bottom, you put B term. B term here, it will be positive 13. And then right here is where you play the number. You're looking for two numbers to put inside here that multiply equal to 30, and you add them together equal to 13. It will be 3 and 10, because 3 times 10 is 30, and 3 plus 10 is 13. So, and now you take x. Here has 3, positive 3, and then positive 10. You're done. That's your factor. Let's try another one. Let's see. Fine. like this one. So once again, before you do anything, try to factor out a GCF if possible. I see that I have 2 here, 40, and 70 here. All the 3 numbers here divided by 2, so therefore 2 must be the GCF, so I'll pull out a 2. And I have this polynomial. And then you can do trial and error method. Always keep the 2 down here. Put the 2 bundle like this. X and X. The minus here tell me I have 2 opposite signs. So I put plus or minus randomly. It's not really matter where you put. 35 is 35 times 1, 5 times 7. These are only 2 possible numbers that multiply equal to 35. So I will pick 5 and 7. Put them randomly and we'll test it. Okay, let's right now pretend that the 2 disappear. You only test from here, go up there. This 2 should be equal to that. Okay, x times x, x squared. 5 times minus 7, 35. You got a middle term here. You take x times minus 7 is minus 7x. 5 times x is 5x. So you add them together, you have minus 2x. So you see, I got exactly what I want. So my answer must be correct. Erase this. Okay. So now this is our answer. Okay. For diamond methods, you can do the same. Draw a cross. So I'm going to do the same thing. First, we look at the problem. I see that the problem have the GCF of 2. I pull out of 2. I have this. Now I'm start from here. So I put minus 35 on top, minus 2 in the bottom. Now the diamond methods, we don't have to worry about the sign because the sign will take care of itself when you do the process here. Find the 2 number here. So I'm looking for 2 numbers that multiply equal to minus 35 and I add together, it has to be equal to minus 5. So that means I must have some minus number here and a positive number here to multiply equal to minus 35. And only 2 numbers, 5 and 7. Okay, so minus 5 times 7 is minus 35. Minus 5 plus 7 is not minus 2. So all you have to do is change the sign. Like that. And then now you just copy x plus 5 and then x minus 5. Then don't forget the 2 here and bring it down. So this is your answer. So you see the answer is the same no matter what method you choose to do. So whatever you feel comfortable, you do the method that you like. For those who have trouble with factoring, maybe you like to learn the diamond method. Let me show you another example. Just 3x squared minus x minus 4. For this example, I'm using a diamond method because it's extremely easy. If you're using the trial and error method, is really a little bit complicated, but the diamond method is very nice. So if you know how to use this by using a trial and error, then you're okay. Now, for the diamond method, if you want to use the diamond methods to solve this problem, the diamond methods only work when the first number, the number in the front here, the leading coefficient, is a number called the leading coefficient, is 1. Since the leading coefficient here is not 1, we're going to have to do some extra work. And it's easy. What you do, you borrow it. You take the 3, you times 4. So you multiply 3. This process is called borrow. So when you do that, the problem becomes x squared minus x minus 12. Then now you do the diamond method. So we put minus 12 here, and then minus 1 there. This one here, you have minus 1. Now ask yourself, is there two numbers you multiply equal to minus 12 and add together equal to minus 1? Which is, well, since this is a minus number, wherever the number going over here has to be the opposite sign to get a minus 12. So it will be, let's try 2 and 6. Minus 2 times 6 times minus 12. Minus 2 times 6 is equal to minus 12, but minus 2 plus 6 is not minus 1. So I know that the answer is not correct. So I will choose 3 and 4. Let's see, 3 and 4, minus 3 times 4 is minus 12. Minus 3 plus 4 is positive 1, not minus 1. So therefore, I should have positive 3 and minus 4 there. Because minus 3, because now positive 3 plus minus 4 is minus 1. And a minus 4 times 3 is a positive, is a negative 12. So we must have the following. So a factor. So I must have x plus 3, x minus 4. Now I'm not finished yet because before we borrow the 3, now we have to pay back. And how do we pay back? We just take the number here, you divide by 3. Take 4 divided by 3. You do not take the x divided by 3, only the number. Take the number here divided by 3. And then you simplify. So you got x plus 1, x minus 4 over 3. Okay. When you factor out, we do not want to have a fraction in the factor. So when you do, is the easy way to get rid of the 3 is you multiply this whole thing here by 3. So if you multiply this whole thing by 3, you will have 3x, because you times this here by 3, and then you times this whole thing by 3. When you times this here by 3, you have 4 over 3 times 3, which is 3 over 1. So you cancel out of 3. You have 4 left. So you have minus 4 here. Okay? So this is your answer by using the diamond method. Now, if you have, if your polynomial have 2 terms, if the polynomial has 2 terms, then you must have a trinomial. And if you have trinomial, try to see if you can use these 2 identities. The first one is called the difference of perfect square, because it has a minus here. And the second one is when you have a plus there. If you have a squared plus b squared, then the polynomial cannot be factored. But if you have a squared minus b squared, you can factor out as a minus b times a plus b. So let's look at this example. I have 4x squared minus 9. So I have a binomial. So I want to see, can I, if this polynomial here can rewrite to look like this or not. Since I have minus right here, I also have minus there. So let's see, I can rewrite this to look like that. If I can, then I can use the property here. Now the 4 can rewrite as 2 squared, x squared. I bring it down. So this here can rewrite as 2x and then the whole thing squared. Because I learned somewhere, I remember that a times b squared equal to a squared times b squared. The equal sign means I can go the opposite. If you have this, I can rewrite as that. So exactly I did right here. And the 9, this 9 here can rewrite as 3 squared. So you see the problem actually the whole problem here can rewrite as 2x squared minus 3 squared. So you see we do have this identity here. So you see that a is 2x and b is 3. So now I'm using that formula to factor out, to have 2x minus 3 times 2x plus 3.